So it's actually not 1-2, this is actually 2-2 because we are in our second unit. We changed the order from last year, so this is actually 2-2. Distance and midpoint in 3D. You will be able to use our two-dimensional formulas that we already know for distance and midpoint, except this time in three-dimensional space. Okay, here's your distance formula. The same type of distance formula that you would need to know for your SAT and ACT was just the x2 minus x1 squared plus y2 minus y1 squared. There was no z. That's for two-dimensional space. But for three-dimensional space, there is a z axis. That's what creates that depth there. And so you just pretty much in a similar fashion, you just continue to add a z2 minus z1 squared. And realize that x1, y1, z1, that's one coordinate, whereas x2, y2, z2 is another coordinate. But it's the same distance formula that you knew from way back then, and it just adds on that third dimension, okay? So when you have to find the distance, and here's your particular example, 6 is your x1, -3 is your y1, and 8 is your z1. -2 is your x2, -10 is your y2, and 1 is your z2. Should be this. Huh?
They're the same points.
Oh, they're the same points? Oh yeah, so we're gonna do distance first. We're gonna do distance first. So then all we do is we just plug it into that formula. It is the square root of x2, which is -2, minus x1, which is 6. We squared that. Then we add it to y2, -10, minus y1, which is a -3, and we square that. And then again, to make it that three-dimensional, because x and y was two-dimensional, we're in three-dimensional now, z2, which is 1, minus z1, which is 8. That gets squared. So -2 minus 6, that's a -8. You square that, plus 2 negatives make it what?
Positive.
A positive, so this actually turns into -10 plus 3, so that's going to be a -7 squared, plus 1 minus 8, which is again another -7 squared. Now do be very careful. Of course, you're able to use your calculator the entire time, but the calculator is only as smart as you are. So if you don't include certain things, you're not going to get the correct solutions. Everybody knows, or should know, that a negative number, when you square it, should produce a what?
Positive.
It should produce a positive number. So you got to make sure that if you type in -8 squared and you want to produce that positive number, you include the parentheses. Otherwise, the calculator is not going to give that to you. And you know this. You know that when you square a negative number, it should give you a positive, right? Yes? Okay, good. So then -8 squared is 64. What about -7 squared? Y'all should know your perfect squares. 49. And then plus 49 one more time. So then we need to add those together. What's 64 plus 49 plus 49?
$162.
162. So this becomes the square root of 162. Now, of course, we can type that into our calculator and we can get the three significant figure approximation. Can someone do that and tell me what it is for 3 significant figures?
$12.806. Oh, 12.8.
12.8?
Yeah, the full number is 12.806.
Double check.
Oh, no, I put 164. Hold on.
Okay, I'm about to say. All right, and in case you're wondering where the square root button is located, you press the second button and you press the X square button, which is about 4 buttons down from that second button.
Okay, 162 is 12.727.
So 3 significant figures would be 12.7. Very good. So then the distance between these 2 points in space would be 12.7 units, okay? 12.7 units. That is the approximation. But because you guys are juniors, you guys are going to be sitting for the SAT and ACT. You are also going to need to know the skill of simplifying radicals. So we're going to do that as well. We are going to simplify this radical as well. When you simplify radicals, you want to find 2 numbers that multiply to give you 162. What 2 numbers multiply to give you 162?
$18 and $9.
18 and 9. Okay. So, when you have 18 and 9, both of those work, and 9 actually is a perfect square. But the thing is that 18 can be broken down some more, can it not? Okay. So let's find 2 other numbers that multiply to give me 162, besides 18 and 9. Everyone should be trying to figure this out. You're unsure, just start dividing numbers into 162. So we have 81 and 2. And again, by finding the largest perfect square, then you won't have to continue to simplify it down. What's the square root of 81? 9. So 9 comes out of the radical, and then you're just left with 2 inside the radical. So 9 square root of 2 would be the exact distance between those 2 points. So this one would be the exact distance. This would be the approximation. The reason why this is the approximation is because we rounded the distance, okay? So be careful of that. If they ask for the exact distance, they want the simplified radical. Midpoint, just like what you knew before, it's not a square bracket, it's still the parentheses because it represents a point. Just to fit everything in, I think you don't get a square bracket that would work, but it's still a parenthesis. And just like with distance, you just add in the z coordinate. So midpoint, 2-dimensional is x1 plus x2 divided by 2, y1 plus y2 divided by 2. But then you add in that 3rd dimension, z1 plus z2 divided by 2. So if I wanted to find the midpoint for our example, we just plug it into our formula. x1 plus x2 all over 2. y1 plus y2 over 2. Then you add in that 3rd dimension, z1 plus z2 over 2.
Is it a column?
These are commas in between them. Yes, these are commas. So then you'll have 6 plus -2, which is
4.
4. Then you'll have -3 plus a -10, which is then you'll have 8 plus 1, which is. So then the midpoint between these 2 points would be 2, -13 over 2, which I know some of you guys are probably going to say -6.5, and that's fine. And then 9 over 2, and some of you guys might say 4.5. Remember, the one downside about decimals is that if it does not go in evenly, now you have to round, and then it's not the exact midpoint. Okay? Questions on using the formulas? Very straightforward, okay? It's very straightforward. The complexity of it is that if you have to graph it or you have to apply it to an application problem, okay? So we're gonna look at a three-dimensional coordinate plane. This is what they look like. All of these are different examples of a three-dimensional coordinate plane. If you guys were actually in the classroom, this is actually a regular class, we would have created a three-dimensional plane. So then that way you have a visual, an actual physical visual that you can hold and you can see it. Because a lot of times students have a hard time identifying what the coordinates are when you're within a coordinate plane. But if you sit in the classroom, or maybe even potentially in a room in your house, if you have a square or a cuboid, a cube type of room, okay, like you think about any of the classrooms in Lake Wales High School, they're kind of shaped that way, that we are in a three-dimensional coordinate plane, okay, where like one wall crease, where two walls come together, that's one axis, where two walls come together, that's another axis, and then where two walls come together, that's another axis, okay? And so I'm gonna make sure that everybody can see this because I'll probably have to reference this. All right, can everybody see me? Can y'all physically see me?
Yes.
Okay, so if I go to this corner of my room, then this crease where the wall where the board is and the wall where this door is, they meet, and then that would be the y-axis in that first picture. Like this crease right here would be the y-axis. All right? Now where this wall and the floor meet, that would be this axis right here, the one that is labeled X in that first picture. And then where the wall, the door with the wall, or the wall with the door and the floor, that will be your other axis, okay? The one thing that you have to be careful of is you need to identify the axes. So then that way you know the order in which you need to put your points, X, Y, and Z. Because compared to the first two and this bottom one, you see how the axes are labeled differently? That's going to affect the order in which you label your points, okay? So you just need to be cautious of that. If you want to try to get a visual here for your own paper, you need to draw a vertical line. Go ahead and label that Z. We'll use this bottom example as your labeling. So this would be your Z axis, okay? Then kind of from the bottom of that Z axis, don't draw it straight across, kind of draw it at a slant. Then that will be your y-axis. And then from again, where those two meet, draw it in a different angle direction and label that X. And then you'll have a three-dimensional plane that you basically have created on your paper. So that's pretty much the notes with the distance and midpoint. Like I said, it really kind of just comes into, you know, applying it and being able to use it in more of an application type of problem, okay? So let's look at an example. This one's easy. I'm not even gonna go to that's two-dimensional. Let's look at this. This is three-dimensional. This is a three-dimensional space. Okay, let me remove that there for right now. It says for the cuboid below, write down the coordinates of point B. Well, first off, here's where B is located. All right? And can everybody see the x-axis, the y-axis, and the z-axis?
Yes.
Does it matter which one you labeled which? As long as you stay consistent, you're fine. And a lot of times, they'll provide the graph for you. So then that way everybody's will be the same.
So if you needed to draw it, you just keep doing it the way that you've done or the example.
Yeah. So now to find the coordinates, okay? Just like before, X comes before Y, and then Y comes before Z. Okay, so we need to place it in that order. So we need to figure out where B is located in retrospect to X, Y, and Z. Your x-axis is the axis that runs diagonally down from our origin 0, 0, 0. How far down is point B? How many units would you say?
6.
It's 6 units down. Because as you can see, here's 6 on my x-axis, and B is basically in that same position from that point. What about Y? Here's my y-axis. Y runs horizontally. So it would have to match up this way. No, not 4. It would be 7.
Because it's the line that's connected. Oh, okay.
Yes, because everybody kind of accidentally drew through it. But there's my Y. Y runs horizontally this time. So as we can see, we're at that 7 spot, and that's where B coordinates to. Z runs straight up.
So that one.
Not for point B, it would be 0. And the reason why is because it's almost like, okay, again, let's use the room as an example. Right here, down here at the bottom is 0, 0, okay? I'm running along my x-axis 6 units. Okay, so that's 1, 2, 3, 4, 5, 6. Okay, now I'm here. Okay, huh? Oh, Jesus, that's right, y'all can't see me. I should be able to see me a good amount in the room. Okay. So here I am at 0, 0, right here in this corner. I'm gonna run 6 units that way. So that's 1, 2, 3, 4, 5, 6. I'm essentially along the wall 6 units. Okay? That was my x-axis. Now my y runs along the front wall and the floor. That's y. I'm going out 7 spaces. That's 1, 2, 3, 4, 5, 6, 7. Yes, you guys can still see me. That is where B is located. Z is the distance going up from this point, 4 units. But B is on the floor. B is on that X, Y plane down here. Like this is that X, Y plane down here at the bottom. So it didn't go up any.
That makes sense.
Does that make sense? What about y'all online? Never thought I had to explain this virtually.
So then, this is a little head, but for A, you count up from B.
And so from A, you would count up from B, yes.
So it's kind of, in geometry, we call this the bunny hop, where you just do the loops.
Uh-huh.
You count to A, you just do that vertical line and do the 1 for every unit. You get 4.
Yeah.
To find Z.
Mm-hmm. So again, the coordinates of B would be 6, 7, and 0. Online, if y'all having a hard time following along, y'all gotta let me know, okay? A is literally right on top of B. So that means that it has the same X and Y coordinates, but its Z is different. Like you said, it would be what for the Z coordinate?
I can't see. 4.
It'll be 4. Because again, Z runs straight up, and we went up the same amount of units to technically make that cuboid. Questions on that? So then we're asked to find the midpoint of M, which is on the diagonal from A to O, okay? O represents the origin. What are the coordinates of the origin? That's in 2-dimensional space. So in 3-dimensional space, it would be 0, 0, 0. So then to find the midpoint between A and O, I would need to use the what? The midpoint formula.
Which one would be your XY, the origin or the one?
Either one, because we're adding, and so it wouldn't make a difference. So let's set it up. What would I write to get my method points?
0 plus 6.
0 plus 6
over 2.
over 2.
0 plus 7 over 2.
0 plus 7 over 2.
0 plus 4.
So then that just becomes 6 over 2, 7 over 2, 4 over 2, which becomes what?
3, 7 over 2.
So in my picture, I'm going to erase all this other stuff. Even though it doesn't ask me to do this, I am going to just do this to emphasize the point. I'll be 3 units on my X, 3.5 units on my Y, and then 2 units up on my Z. So this will be my point. This will be my midpoint. And before I erased it, that does lie on that line that connects them. So from that corner to that corner represents from A to O, essentially. And we have found the point that lies smack dab in the middle, of that line. Okay? If anything, pretend like it was my head represents that midpoint, because I was a part of that line. Okay? When you don't have to graph, you just have to be able to apply everything. Okay? We're going to hold off on this one because it's a 2-dimensional one, so we'll come back to it. Somebody remind me to come back to that one. This one here, we have 2 more examples, and then we'll go back to that 2-dimensional one. It says a tracking station lies at the origin of a coordinate system with the x-axis due east, the y-axis due north, and the z-axis vertically. Does everybody know their compass points? Never eat soggy waffles. Where's the N? And then I go which direction? So this will be very good. So basically, they're giving you your, they're basically telling you where your x-axis, your y-axis are. X is due east, so that means they're running along that east horizontally. Y-axis is due north, and the z-axis is vertically. But essentially, we have 2 aircrafts that have the coordinates of 20, 25, and 11, and 26, 31, and 12, relative to the tracking station, which is located at the origin. What's the coordinates of the origin again?
0, 0, 0.
Wonderful. So what I want you guys to do on your paper, I want you to find the distance between the 2 aircrafts at this time. And then we'll come back together and do B together. So you guys are finding the distance between the 2 aircrafts, which have these 2 respective coordinates. You're finding the distance between them. So I'm trying to find the distance between the 2 aircrafts at this time. Hopefully you guys made this X2, Y2, and Z2. So then I would have 26 minus 20 squared plus 31 minus 25 squared plus 12 minus 11 squared. We know that 26 minus 20 is 6. 31 minus 25 is 6 again. And 12 minus 11 is 1. So when we square each of those, we'll have 36 plus 36 plus 1, and that equals the square root of 73. So our distance is going to be 73 units, or around the three significant figures, 8.4 units. Now part B says that the radar at a tracking station has a range of 40 kilometers. Determine whether it will be able to detect both aircrafts. And radar is used by air traffic controllers and tower, or even down in ships and submarines and things like that. It's basically this machine that has their location in the center of it, and is saying that it can go out 40 kilometers. This radar is tracking. What shape did I draw again? A circle. And then these lines that I drew with the 40 kilometers, we call the what? The radius. So the tracking station is located smack dab in the middle. That's how the radar has its range. So if this is located at the origin, which is 0, 0, 0, then we have to figure out whether or not it will be able to detect both aircrafts. So we have to find the distance from the tracking station to A, and then the tracking station to B. So that's what I want you to do. I want you to find the distance from the tracking station to aircraft A, and this tracking station to aircraft B. When you have it, type your answers into the chat, online students. So the distance from the origin to the first aircraft, A, what'd you guys get?
33.9 km.
Yes, 33.9 kilometers. What about from O to B?
42.2 kilometers.
42.2 kilometers. Very good. Now, of course, it says determine whether it will be able to detect both aircrafts. You want to make sure that you would include the work that's associated with how you got those numbers. Because remember, if you're trying to explain or determine and justify, they want to see the math that goes along with it. So you want to make sure, which I'm pretty sure you guys did on your paper. I'm just making sure to re-emphasize. Can it detect both aircrafts?
No, we can only detect aircraft.
It can detect only the aircraft that's at the coordinates 20, 25, and 11. Okay? So if this says explain if it can detect instead, you want to show the math, and as we can see, 42.2 is outside of the range of that radar. Okay? Good stuff. Now we're going to look at this one. We're going to talk about this one. We're not going to do this one all the way out. I just want to make sure that everybody understands how we go about doing this. It says a ski resort is designing 2 new ski lifts. One lift connects station B at the base of the mountain and station P at the top of a ski run. The other lift connects station P with station Q, which is at the top of another ski run. So basically, you have the base of the mountain, you have P, which is located at the top of one ski lift, and then you have Q, which is located at another top of a ski lift. Okay? So, mountain, there we go. And there's a ski run that runs from one to the other. Now, the 3 stations are placed on a 3-dimensional coordinate system. B is located 0, 0, 0, which makes sense. It's the base of the mountain. P is located at 500, 400, 300. And Q is located at 900, 600, 700. A skier wishes to reach the top of the run located at P from the base of the mountain. Determine the distance covered by the skier on the ski lift from the base of the mountain to P. How would I figure that out? I would use the distance formula. The distance from which to which?
B or B.
B to P. Because I'm going from the base of the mountain to the top of the ski lift on top of the mountain to P. That's why it's only 2 marks, using the distance formula. But the last one is 3 marks. It says in order for the skier to reach the top of the ski run at Q, they must take a lift from the base of the mountain to P and then take a separate lift from P to Q. Determine the total distance covered by the skier on the ski lifts from the base of the mountain to Q. How would I figure that out?
Would you find the distance separately then add them together?
Yes, I'll find the distance separately. So I have to find the distance of which
PQ.
PQ.
Because you would already know the distance of P because it's in the other one, previous question.
Correct.
And you just add them together.
Very good. And that's why this one is worth more marks than the first one. And do realize, I don't know if anybody's ever been skiing, but it's very rare that you can go from the bottom of one point on the mountain to the very top of another one. A lot of times you have to connect from one to the other. There's no straight distance there, okay? A lot of times they don't have those in those mountains.
Especially if it's super high one, it has to be at a different mountain because it runs against it.
Right, exactly. Okay, I don't know if you ever heard Koski, but yeah, if it's really, really high, I don't think anybody would want to get on a wire inside of a little cubicle that looks like one of those little things you ride and like on a Ferris wheel
You only have a bar.
up in space, not space, but in air to the top of a mountain. I don't know about you, I'm not riding. Okay, definitely not. About to ski and fall off the side of a mountain? No, thank you. Those are for the pros. But that's how you would do that. So good stuff. I did want to go back to this one. It's still dealing with distance, but it's in a two-dimensional system. You guys did a few of these when you did your con assignment, but not one with distance. It says the distance between two towns, P and Q, is 2 kilometers. So the distance between P and Q is equal to 2. On a coordinate plane system, town P has the coordinates of x7 and Q has the coordinates of 3, 5. The values of the coordinates are given in kilometers. Find the value of x. How can I set this up to solve this?
This is when we put the X in here, it should be for X1, X2.
Okay, so I need to use this is formula, and you said I need to plug in. So set it up for me.
Parentheses 3 minus X parentheses the second power plus 5 minus 7 the second power.
Anything else?
That's to set it up.
That's to set it up, okay. But how am I gonna be able to solve for x? I need something else.
Would you set it equal to 2?
I would need to set it equal to 2 because remember that represents the distance. Now I can actually solve for x. Before I could just simplify. Now I can actually solve for x. That's what I want you guys to do. Solve for x. Do that now. Online, as you know, type in your answer once you have it.
You want to go first?
Daniel, how'd you do it? What'd you do?
So first, distributed the 2 exponents, so it was 9 minus x squared.
Okay, so right there, you gotta be careful. When you do 3 minus x squared, that's the same thing as saying 3 minus x times 3 minus x, so you have to FOIL. So that's one thing right there, okay? How'd you start off?
I combined them. I got negative 3x squared plus and negative 2 in the second power. Like I just
Oh, you can't combine like that, okay? So I know negative 2 squared is 4. So right now I have 3 minus x squared plus 4 is equal to 2. I'm trying to solve for x, so that means I gotta get it by itself. How do I undo a square root? How do I get rid of a square root? I square it. Not just that side, but I need to square the other side. So then that'll give me 3 minus x squared plus 4 is equal to 4. Now what can I do?
You wouldn't square the 4.
No, because since it was underneath the square root, that squaring only got rid of the square root.
Oh, okay.
What can I do from here?
Minus 4.
I can minus 4, so that'll give me 3 minus x squared equals 0. Because if I subtract 4 over, 4 minus 4 is 0. Oh no! Laptop's dying. I was like, why is it starting to glitch on me? This always happens when my laptop's dying. Caught it in time. Almost lost everybody. Okay. Now say what?
Would you foil again?
I can FOIL. So if I FOIL this, it becomes 9 minus 6x plus x squared equals 0, because I FOILed this. Let me write it the right way.
Wait, Miss Anderson,
Yes?
why did you square the 2?
Why did I square the 2? Oh, because the formula. Remember, it's x2 minus x1 squared plus y2 minus y1 squared. So after I subtracted 5 minus 7, I still had to square it because it was a part of the formula for distance.
Oh, okay, thank you.
Mm-hmm. How's it gonna help me? What do I do from here?
Do you do the thing with the x factor?
Yep. I'm looking for two numbers that multiply give me, that add together give me, and they are?
-3.
So this becomes x minus 3, x minus 3. So when I set both of these equal to 0, what does x equal? 3. I could have also, from this point, I could have also taken the square root of both sides to get 3 minus x equals 0, because the square root of 0 is 0.
And then you just add x over.
But I'm glad we went over factoring though, because I definitely would want to do that. But yes, simple concept is a formula. You just have to be able to apply it. That's the main thing. Now you're able to do it as well with three-dimensional space.